Hello everyone, myself Sneha Katole, and this is the third lecture on database management system. So today we will be discussing about server system architectures. Um, Server system architectures are categorized into transaction servers and data servers. So transaction servers are also query servers. So query server system where clients and server are interacting in such a way that clients ship transactions to the server. Server executes those transactions and results are shipped back to the clients. And in the form of a user interface and application programs, the data is displayed to the clients. So these requests may be specified using SQL or a specialized application programming interface. So data server systems, which in which client is asking for the permissions for making changes to the database, like modifying the database. So, uh, like in case of file systems, how we have create, update, read or delete options, functionalities by the clients, right? Like clients can perform all these functions. Similarly, uh, in case of database systems, client make requests to perform those functionalities to the server, and then uh, server gives a permission for the mm, client to perform those operations on the database. And in case of database systems, inconsistencies are not happening. Like in case of file systems, inconsistencies occur where changes made are not reflected in every uh, part of the in every file, which is mm, uh, in every user who has access to the file. Only it is local to the particular user of the file system. But in case of database system, as they are connected to each other with the help of server, with the help of data server, clients are connected and hence data inconsistencies are prevented. Classification of the database management system. So further different categories are there based on which database management system are classified based on data model, relational data model, and object-oriented data model. This is the classification. In case of user numbers, we have single user system, multi-user system. In case of database distribution, we have centralized and distributed database management system. In case of distributed, we have homogeneous and heterogeneous database management system. So in case of databases, uh, single user system is a centralized system. Multi-user is distributed. And let's see. So single user system where it is local system. In case of multi-user system, we have a distributed system where all of the clients are connected to the server with the help of a network. This is single user is again one tier architecture that we discussed in the previous session, and multi-user is decentralized, distributed. So this is centralized and decentralized. Why database design is important? So database designs, they are the blueprints of how the data is going to be stored in the system, how the database is going to function, going how the structure of a database is basically going to be. So designing, giving a proper database design is essential. Giving same as providing a blueprint for a building to rise. Proper design of a database, it affects the overall performance of any application. It gives a clearer idea of how an application is going to behave, how it is going to uh, process the requests of the data transaction communication. Also, a proper design of a database meets all the requirements of the users, and the processing time is greatly reduced and latency time is greatly reduced if the constraints of the database design are properly implemented. So database design process. Database design, what is database design? Which is a process, which is the number of processes which enhances the designing, development, implementation, and maintenance of enterprise data management system. So as we understand the phases of database design, we will understand what this means. Mapping conceptual data into implementation models. So phases include requirement collection analysis, conceptual database design, choice of a DBMS, data model mapping, that is logical database design, physical database design, and database system implementation and tuning. So we will go through all of these in detail. So see, in case of database design, so we have conceptual design, choice of then wait conceptual database design, choice of a DBMS, logical database design, physical database design, and finally database implementation. Okay, this is the database design. Then we have application planning, design, and implementation on another side. So both of these are designed independently and then they are connected for testing together, and then further maintenance is done to improve the user experience. So phases of database design, where first phase is requirement collection and gathering and analysis. So requirements are gathered by identifying the users and interacting with those users for what they require, right? That's the first phase. Then we have conceptual database design, where we provide a conceptual schema, conceptual design of a database which is independent of specific DBMS and also independent of a particular system, which involves two parallel activities, which includes conceptual schema design and transaction and application design. So that's the part where we are talking about application design, application planning, application design, and implementation. That's the application design and conceptual schema design. These two are connected and then tested together, right? The in the flowchart we have seen here. So that's conceptual database design. So we'll talk about conceptual schema design. So conceptual schema design, we have two approaches: centralized and view integration approach. Centralized, it is one shot approach where different user groups and different applications are merged into a single requirement, single set of requirements, and single schema is designed. But it places burden on database. It places burden on application like schema design, right? So it is not an efficient way to approach, efficient approach for schema design. In case of view integration approach, what we do is for each user group or application, we build different schema. We design different schema and then they are merged together into a global conceptual schema during the view integration process. So it is a more practical approach. So for the strategies of schema design, we have top-down and bottom-up approach. Top-down, where is highest level abstraction, and then successfully top-down refinements. For example, faculty teaches courses as well as offers seminars, so top to down, right? So we have faculty as the highest level abstraction and then top-down requirements. Case of bottom-up strategy, whereas we what we do is we have a basic abstraction and then we combine this to add to this abstraction. So what happens is we have a faculty, we have staff, we have students. These are the basic abstractions. So and we combine these to add to the abstractions like faculty is a vehicle owner, staff is a vehicle owner, student is a vehicle owner. So combining these basic level abstraction to add to form a bottom-up strategy. So strategies for schema design, inside out and mixed strategy. Mixed strategy, like we have seen top-down and bottom-up combination of those forms a mixed strategy. Inside out, we have a central set of concepts and we increase the scope of those concepts, right? By considering new concepts outside the vicinity of those concepts that we have discussed and decided previously. Phases. So continuing the phases, first of all, we had requirement collection gathering, then conceptual database design. Now we have choice of a DBMS. So many factors are responsible for deciding on the choice of a DBMS, which includes technical factors like What is the type of a DBMS? We have relational object oriented type, where we need, if we have a single user system, multi-user system, we need a centralized or distributed system, right? Then storage structures also matter, like what format of storage structure we have. Then architectural options, economic factors to consider are acquisition, maintenance, training and operation costs, database creation and conversion cost. All these factors, organizational philosophy, relational, object oriented, vendor performance, familiarity of staff with the system, availability of vendor services. All these factors, system designers have to work on this. Database designers have to work on this to consider and decide for the choice of DBMS. Then we have fourth phase, which is logical database design, where data model mapping takes place. So what we do is the conceptual schema that we have developed in the second phase, we start mapping it or converting it to data model of the chosen DBMS. So this is of a chosen DBMS. So we are making it a data model dependent design. We are making a data model dependent design, but it is still system independent, right? That's what we do in logical database design. Physical database design, what we do is we have developed a data model dependent data model dependent design of the database. Now what we do is we make it system dependent, like we consider the physical storage structures, record placement and indexes. That is, we consider the physical attributes of a database design for the database design. So we are converting it from system independent to system dependent based on the system that we have to make it compatible. Right. So last phase, database system implementation and tuning, where we perform the testing, right? We perform the testing of the application programs and the database which are implemented, they're first implemented, that they're tested, and then they're deployed for the service. So we are making the tests independently of for each subpart, and then we're combining them and perform the tests. So implementation is basically testing it in the real time and using it, making it available to the user in real time. So that's about it. And tuning, yeah, the database system tuning. So what we do is, as we implement the systems, we identify the opportunities for making changes, like wherever the improvements are essential, we identify those opportunities and make changes to those. So for system maintenance and improvements and for user ease, we perform the tuning, and it continues throughout the life cycle of a database. As the application keeps evolving and performance problems are detected, tuning occurs, and that's it about phases of database design. So that's it about today's video. Drop in any questions if you like. Thank you so much for watching this video.